Hey everyone, this week we are going to be getting into batting orders. This time we're going to extract batting orders for each game in the 2019 season, as well as being able to see how many times each spot in the batting lineup appeared in a game over the 2019 season. So, first, as always, we will load in our libraries, Baseball R and Tidyverse. They're already loaded for me. And then we'll load our whatever your Savant data set is, either a CSV file or an SQLite file from my videos. So whatever your Savant file is, load that in there as well. Next, what we'll do is we will create a game IDs data frame. So game IDs data frame. And then what we'll do is just say game pack. And we'll say unique Savant game pack or game primary key, whatever you want to call it. But that way we have those games listed in our data set. I'm going to create a loop again, a for loop, by calling our list. So we'll say orders list, and then for I in 1, 2, number of row, game IDs, create that squiggly bracket to indicate what we want in our loop. And here's what we'll do. We'll do orders I to indicate what listener element we want. And then we'll say get batting orders from the Baseball R package. Game IDs, game primary key I, and then we'll say type equals all so that we can get all substitutions and things of that nature. And then we want to add a column called game primary key, which you should know what it is. It's just getting that game pack. So that way, when we do a merge statement with the Savant data set, we can have actually both of those things, both the ID and kind of the batter type. I'm not going to run this code since I already have it, but make sure you do run this code. It does take a bit of time, so if you have a slower machine, don't forget to add a system sleep. I've mentioned that before. But once it's done running, now we can get it into a data frame. So we'll call it batting orders, and we'll say plier, LD ply, and we'll say orders, data frame. So now we have that data frame of observations, and you kind of see ID, full name, abbreviation, batting order, batting position number, team name, team ID, game pack. We're not going to keep all of these variables. You can if you want, but what I'll do next is say batting orders, and then we'll say batting orders again, and that piping operator, rename batter equals ID. And then, again, solely up to you, but I will select batter. Let's see what else. Batter, abbreviation, batting order, and then game pack. So then we'll run this, and now we have a broken down subset of that data, since we already have the player names in the Savant data. We're going to first break down the Savant data set into just plate appearances. So one way to do that is actually through Baseball R as well. We're going to say Savant run expectancy code. We'll say Savant, and then level equals plate appearance. That way we have the plate appearance data and broken down. So one thing I will mention though, I know I have two different videos kind of showing you how to get StatCast data. I found out that there's actually two different observations. So the first one that I did was had about 729,000 and so on observations, whereas the other one had about 794,000. That 794,000 one does have some duplicate games, so I would recommend if you did that, go back to the first video and run that code. That way you do have the non-duplicated games. So now that we run this, I'll create a sample. So sample equals Savant, sample n equals 10. And we'll look at 10 samples. So we can kind of go to the end here. And it gives you something like final pitch at bat, run scored on pitch, bat score, stuff like that, run expectancy. So we can actually do something with that for these batting orders. And create a merge statement. And how you do that is simply saying Savant merge Savant, that batting orders data frame that we created, by, and then this time we'll actually do two methods. So we'll say by C, which stands for combine, batter and game PK, which then gives us merging those statements by both the batter ID in this batting orders and then game primary key. So that way, in case a player bats third in one game and bats fourth in another. So we'll run that. Give it a minute or two, but it's good to go. And now we want to arrange these games by game primary key, inning, at bat number, and pitch number. So that way we can kind of go game by game and then it's in order. So bat number, pitch number. So I'll run this. Then, since the Savant data set has the batting order now, unfortunately it's not in a numeric variable, so we'll convert it to a numeric variable quickly by doing this. Savant batting order equals as dot numeric Savant batting order. So run this, and now it should be in a numeric. So actually I'll pull this up and you can kind of see all the columns. So we can kind of see abbreviation, batting order, stuff like that. So now what I'm going to check next is if there's any NAs in batting order. So we'll say sum is dot NA Savant batting order. And there are none. So that's great, because now we can go into kind of some factoring and adjusting. So now, even though I just converted it to numeric, just in case, so that way if there were NAs, we could manipulate that. But now we're going to convert it straight into a factor. And again, how you do that is Savant batting order equals as factor Savant batting order. So that way the factor has levels, 1, and 2, you can be able to manipulate it to get kind of the games that you want. So what we'll do next is actually we'll add a few columns. And the reason why I do that is so we can kind of separate between American League and home, American League and National League games, and then be able to see like the average plate appearances for those games. So first we'll say mutate run scored on pitch, and we'll say col-esque, which essentially means that we're going to replace those runs scored on pitch that have NAs with 0. So now we have those 0 instances, and then we're going to say batting, if else, inning top bot, which is just top or bottom of the inning, equals top, then we'll say away team, or otherwise home team. So that way we have who's up at the plate and who's fielding as well. So if else, same thing. Inning top bot equals top, then away team, otherwise home team. But we'll actually switch this around. So fielding. So now we have those 3 extra columns. And now what I'll do next is create a team's data frame, and then I'll read in a CSV file. I will link this CSV file on my GitHub page for this code. I always add my GitHub under in the description for my channel. So for each video in the GitHub page, you'll find this CSV file that I'm sharing with you. So team leagues.csv, it basically gives you the league of each team in Major League Baseball. So now what we're going to do is we're going to separate it by home and away teams. So home teams, piping operator, select home team, and then home league. And then same goes for away. So away equals teams, select away team, and then away league. So that way we have both home and away data and information ready to go. Now we're going to add that to the Savant dataset. So we'll say Savant equals, and we'll do a left join, which is a kind of SQL operator where all of the information in the Savant dataset will remain the same, and then whatever matching columns are in the right dataset, in this case it'll be home team and away team, will go into the dataset. So I'll say left join Savant home, and that's the other set, and then we'll say by equals home underscore team. And similarly, again, Savant left join Savant away by away team. So we'll have both of that data as well. So we'll run this, go into Savant, get all of the columns towards the end that we added. So we added batting, we added fielding, we added the home league and away league. So that way we can then do kind of how many plate appearances does each batting order get as a whole in Major League Baseball, then break it down even further by in American League games or in National League games. I do have code written, but I'm going to break it down for you. So what we're doing is we're from the Savant dataset, we're using a piping operator, we're grouping by batting order. Then we're going to summarize plate appearances per game equals length of batting order divided by total amount of MLB games in 2019, which is 4,858. And then we'll get the average run expectancy for each batting order. Then runs driven in per PA, because this is not really saying runs scored per PA, but runs driven in per PA, because it's measuring how many runs were scored on that pitch or that at bat. And we're going to divide that by the length of the batting order, so length of each batting spot. And then Wobacon, which is weighted on base average on contact, is the average of the estimated WOBA using speed angle. And we're going to remove any NAs there, as well as we're going to get the average exit velocity of the mean of the launch speed, which is exit velocity, and remove NAs as well. So we're going to run this, and we can kind of see the leadoff spot gets 4.68 plate appearances per game, second spot 4.57, third spot 4.45, and it kind of goes down. The average run expectancy seems to be highest for the second and third spots, which makes sense, because those are probably your best hitters. And then we can see like runs driven in per PA. This also makes sense. You know, the 3, 4, 5 hole will usually have more runs driven in per PA because of these first two spots being more on base driven. And then Wobacon, so you can kind of see weighted on base average on contact. Seems to be highest for the 3 and 4 holes, also makes sense. Exit velocity seems to be the hardest for the 3 and 4 holes as well. So this is actually some pretty cool stuff. Then we can kind of break it down even further and say AL equals Savant filter home league, we'll say equals American League. So that way it's just broken down by American League. And now we can say, I'll copy and paste this, but this time divide it in half. So instead of saying 4,858, we'll say 2,429. It's half the American League games. And then instead of saying Savant, we'll say AL. So that way we're going to see how much different does it look in the American League compared to the league as a whole. So looks like you get 1/100th of a plate appearance more per game on a per game basis from the leadoff spot and the 3 spot. So looks like you're getting more plate appearances from the first 3 spots in the order, especially one more in the 4 spot. But again, like the run expectancy is highest for 2 spots here. More runs driven per PA again makes sense. So it aligns pretty well in this area. And then you can kind of go with this as well and go National League now. So that's what we're going to do. We're going to go National League, Savant, filter home league equals National League. Now we may see some differences here as well. So we'll run this. So definitely the run expectancy drops a little bit, which I think makes sense because the pitcher spot usually bats 9th. And usually, I mean, that's mostly an out. Anyways, so, and then a lot less runs driven per PA than, say, the leadoff spot, because again, no DH, so that pitcher spot usually will be an out, and there's less guys. But you can kind of break that down, and you can do a lot more with this. So I just scratched the surface. Some of the ideas that come to my mind is, what are the average amount of runners on base when that lineup spot comes up? How often does that lineup spot lead off? How often, or how much does that change? So if you want me to do a supplemental video on that, I'd be more than happy to. Or if you want to do, like team specific or player specific, if we moved certain players. So like, what if Mike Trout hit leadoff instead of second? Or something that the Cubs were planning to do this season, having Chris Bryant hit leadoff. How much would that change? So actually what I'll do is break it down by the Angels. So we'll say AL, we'll say LAA, Savant, Filter, Home League, or I'll say batting equals LAA. So that way we have all of the Angels data. And then we'll break this down. Since they played 162, we'll say 162. So we'll run all this. So, I mean, based on this, we assume that Mike Trout hits in the second spot. He has more runs driven per PA. His Wobacon way higher. His run expectancy is lower, which, I mean, as a whole might actually, no, it's way higher. Excuse me, sorry about that. But you can see, like, how much different does Mike Trout hitting second, and he has 4.52 plate appearance. So he actually has a little bit less than, say, the league average in the American League. So I find that pretty interesting. And again, if you want me to do a supplemental video on this, I'd be more than happy to, because another way that thing that pops into my mind is you can kind of measure, how much does having Mike Trout hit in the second spot is better than having a league average kind of run expectancy or runs driven in per PA in that spot. So again, thanks for watching. Really appreciate you taking the time out to learn more about R. And if you want to see more of my content, please like and subscribe. I really appreciate it. And if you want to become a Patreon donor, please donate to my Patreon. Any donation is greatly appreciated. So helps me make even better content in the future. But thank you for watching. Have a great rest of your day.